I'm Satoru Takeuchi, working for a Japanese company, Cybozu, and I'm one of the maintainer of Rook. I'll have a presentation about the BlueStore data corruption bugs, which Cybozu encountered in our containerized Ceph cluster, in the development of containerized Ceph cluster. So here is the table of contents of today's presentation. And I first introduce Cybozu and our infrastructure, and then next, what kind of bugs we have revealed in the development of our infrastructures. And next, I will introduce why we hit these bugs. And next, proposals. I'll have a proposal to improve the official QA process. So I'd like to share this information. And the last, conclude and summarize my presentations. So let's start first, Cybozu and our infrastructures. So what is Cybozu? So I guess most of people doesn't know Cybozu. Cybozu is a Japanese the leading cloud service provider in Japan and providing software that supports teamwork. So our Cybozu infrastructure is there are two kinds of two infrastructures: the current one and the new one. The current infrastructure is a traditional virtual machine-based system, and we used this system for 10 or 20 years or so, and this architecture is quite old, and there are many limitations in storage capacity or performance problem or something. So we are developing new modern modern containerized infrastructures based on Kubernetes, and we also use Rook Ceph as a storage in this Kubernetes cluster. I guess some people doesn't know about Rook. Rook is Ceph orchestration on top of Kubernetes. So our next infrastructure is containerized system. So let me introduce the characteristics of modern containerized systems. So modern containerized system is easy to deploy and manage than traditional system. In this case, traditional system means running workload, for example, end users workload on top of the bare metal systems or the virtual machines. But the containerized system, of course, running these workload on top of containers. So from nature of easy to deployment or management, we start both nodes and containers frequently in containerized system. And usually, containerized system runs integration test per request. And running integration test per request in itself is not so. Is running integration test per PR is common. For example, Ceph also running their own test per request, but container-based system create and restart containers during test many times. And in about Rook, the OSD and manager and monitor is expressed in container in Rook. So it means in Rook Ceph cluster means creating, restarting OSDs or monitor or something frequently. So the characteristics of the development of our infrastructure is consist of two parts. The one is creating Ceph cluster frequently, And the second one is create and restart OSDs frequently, as described before, as described in the previous slide. So let me introduce our development strategy. This strategy consists of 3 steps. So first step is that every changes to our infrastructure, each change is expressed as a pull request. Every change kicks integration test in virtual machine-based test environment. Each test environment emulates the full data center having 2 Rook Ceph clusters. In this case, 2 Rook Ceph cluster is the first cluster is for RGW, and the second one is for RBD, block devices. And in this case, the VM-based text environment means that create one big virtual machines and create several virtual machine on top of this big virtual machine. So it says we use nested virtualization. Several VMs worked as node in Kubernetes cluster, and so we create a Rook Ceph cluster on top of that Kubernetes cluster. This Kubernetes cluster is on top of the small virtual machines. So the second step is that if each integration test pass, apply changes to on-premise staging system. In other words, the staging system means test systems or development systems. So if the staging system works fine, apply changes to the on-premise production system. So in the future, our end users' workload runs on this production system. So the previous slide, I explained that in our development, create and restart OSDs frequently. So let me introduce when we create or restart OSDs. This consists of 2 parts. The first one is we create and restart OSDs for each integration test. We create 2 Rook Ceph clusters. It emulates our data center and the 2 Rook Ceph clusters. So there are over 10 OSDs there are over 10 OSDs in 2 Rook Ceph clusters. And in this test, we also restart all nodes to confirm whether our upgrade the process of clusters works or not. So restarting all nodes implies restart all OSDs. And this integration test runs over 10 times a day. So the second part is we restart all nodes of the staging environment once per week. It's to verify our infrastructure's availability and update the node firmwares. So in this case, infrastructure's availability is not only Rook Ceph cluster but also Kubernetes cluster and the physical instruments underneath. In our staging environment, this environment has about 100 OSDs for now. Not so big cluster. So I estimated the number of OSD creation and restart. I estimated this is estimated values from our test logs or operation logs. It means 3,000 times per month OSD creation or restart. And I'm not sure about the other people's clusters, but I believe that it's a far larger number than the traditional non-containerized Ceph clusters. I'll mention this data after these presentations. So next topic is what kind of bugs we have reviewed. So the bugs we have reviewed consist of two parts and two kind of bug. We find two kind of bugs. The three bug is about failing to create any OSDs, and two bugs about BlueFS corruption just after restarting an OSDs. So let me introduce all five bugs briefly. The first bug is failed to initialize OSD in Rook. The issue title is include Rook, but it's not not Rook's bug, but it's actually Ceph's bug. So it's due to the inconsistency of write IO and fixed by this PR. The second one is also failed to prepare new OSDs due to BlueStore MKFS failure by EIO. It's unfortunately not fixed yet. The third one is it's also failed to prepare OSD. It succeeded to prepare a new OSD, but failed to start this OSD. This bug is also not fixed yet. So the fourth one is RocksDB crash, and it's in this case BlueFS corruption just after restarting an OSD. It's due to collision between BlueFS and BlueStore default write, and the developer, I guess, if I recall correctly, Igor, he said that this problem is probably fixed by this PR, and I'll confirm, I verify when I upgrade our cluster from Pacific to Quincy. The last one is also BlueFS corruption. So it also happened BlueFS corruption just after restarting an OSDs. It's honestly due to the lack of mutual exclusion in Rook. It's strictly speaking, it's not a Ceph's bug, but Rook's bug, and fixed by Rook's PR. So I briefly introduced Firebug, and there are additional informations. The first one is that we hit many of these bugs for the first time. Anyone didn't detected these bugs before Cybozu detected these bugs. And most bugs were detected in OSD on HDD. So I don't know the detail, but I can say HDD seems to be good for detecting this kind of bug, and this is probably due to the HDD is slow and easy to incur race condition, some kind of race condition or something. And the last important things is all these 5 bugs can be reproduced by stress test. As I described, I reported all bugs to Ceph issue trackers, and I confirmed that all bugs are reproduced by creating or restarting OSDs continuously. It's a very simple test. So the next one is why we hit these bugs. Why we can hit these bugs. So as a result of our investigation, my questions are why Cybozu hit these bugs for the first time, and why Ceph's official QA process or other users hasn't detected these bugs. My hypothesis is I have two hypotheses. The first one is the number of OSD creation and reset in Cybozu is far larger than the official QA. As I said before, Cybozu creating or resetting OSDs 3,000 per month, or I guess so. In Sepia Labs, the number is less than Cybozu, I guess. And the second assumption is that second hypothesis is that the official QA hasn't used HDD for OSDs. So I tried to verify my hypothesis. So about the number of OSD creation and reset, I estimated the number of OSD creation were set in the official QA. The original data is from the records of palpitoceph.com. It's the data. It's a database of Sepia Lab during September 2022. So during this time, Sepia Lab was fine. Unfortunately, it's currently it's breaking. It's corrupted, but anyway, in September it was fine. So I record. I read all records during September, and I estimated that the OSD creation is over 120,000 times per month. It comes from the about 30,000 jobs by times about 4 OSDs per test. In other words, jobs. So about OSD research, it's less than 500 times per month. It's far lesser than the OSD creation. It's because the OSD research only happened in the upgrade test, and the number of upgrade cases is very small. If I recall correctly, it's about 10 or 20 or something. Anyway, it's very small number. And this kind of test usually only runs before the new releases. So it means that the often release tests usually run only releasing, for example, V17, 17.2.3 over 4 or 5, and it's not tested before merging pull request. So let's comparing the numbers. The about number of OSD creation per month. It's the official QA. The number of in official QA is far larger than the Cybozu. So my hypotheses were not correct about OSD creation. So as for number of OSD reset per month, it's the number of Cybozu is far larger than the official QA. Let me introduce the number of nodes in Cybozu is far lower than the Sepia Labs, but the number of OSD reset is far larger in Cybozu. So my hypothesis, my second hypothesis is correct about OSD reset. So I also tried to confirm that whether official QA process use HDD or not. So I found that data in the Sepia Labs wiki, and I found the list of machines which used in Sepia Lab. Many machines in Sepia Lab have both HDD and NVMe SSD. So yes, these in Sepia Lab there are machines having HDD. So I couldn't find whether the official QA uses HDD for OSD or not. So please let me know if you, for example, the QA engineers, if you know anything about it. So as a result of my investigation, I have two proposals to improve the official QA process. The first one is adding the stress test about restarting OSDs. So it would be nice to detect BlueFS corruption bugs just after restarting OSD. So let's assume that if we use 10 OSDs and restarting one OSD takes 3 minutes, number of restarting OSD is about 5,000 per day, 5,000 times per day. So the reference in Cybozu and development, the number is 3,000 times per month and 500 times per month in the official QA currently. So if we add the stress test, this stress test, we can run the far larger number of OSD restart in one day, just one day. So the second proposal is that if the official QA hasn't used HDD for OSDs, it's just my assumption. Using them would improve the official QA, and it also makes the stress test of restarting OSDs better, I guess. So the conclusion is that the development of Cybozu's modern containerized Ceph clusters revealed many BlueFS corruption bugs. And the key factors are the frequency of the creating and restarting OSDs, and the OSD on HDD tended to detect these bugs. And my proposal is the official QA would be better if adding the stress test of restarting OSD and use HDD for OSD. Of course, if it hasn't been used. That's all. Thank you. Any question? So if I should contact the QA engineers in the safe issue trackers, I'll do it. Nothing? Okay, so thank you very much all. My presentation is finished.